My name is Cole Nebaker. I am the Training and Events Manager at PDK, and today we are going to be talking about readers and communication technologies. This is a topic frequently out in the field that I have seen is a area of confusion for people, so I'm very excited for this and to cover how readers work and why the credential type matters. Now, as always, be sure to like and subscribe and hit the bell icon so that you don't miss any future access control coaching sessions. Additionally, do not forget to leave your questions in the comments box, the same place where Mike and I have just posted, and we will get to those questions at the end of the video. Keep in mind there is a 30-second delay, so the sooner you can get your questions in, the better it is. Okay, let's jump right into it. All right, now let's cover what a reader is and how it works, okay? So first off, we have our reader that uses an electromagnetic, or in other words, a radio signal. You can see on the left there is a disassembled reader, kind of showing you what it looks like on the inside. You can see that there's a copper coil going around the perimeter of the reader. And in the middle, there's a green circuit board, and in the middle of that, there is a little black circle. That is your piezo. But all of those perform different purposes, okay? So let's start with the copper coil around the outside. So the copper coil is going to be the thing producing the electromagnetic signals. In other words, that's going to be the radio antenna. And that is going to be powered and providing pulses or electromagnetic fields around the perimeter of the reader. Now, the credential functions somewhat similarly, except it is unpowered. It is a little PVC, typically plastic sort of material with a copper coil on the inside and no battery per se. And the way it works is that reader provides this electromagnetic field around the reader, and when the credential comes in contact, it becomes energized and it starts producing its own radio signal, which can then be received by the reader and in turn translated into binary. Credentials are pretty cool. You have very basic credentials like prox credentials, which are basically just energizing and producing, let's say, 26 bits of information back to the reader. But you also have something maybe a little more advanced, like a smart card. The smart card is effectively a miniature computer. It has its own built-in processor, and it has its own little memory bank and maybe encryption key and maybe some other host of information being hosted on it, 4K, 8K credentials. And when it's energized, it effectively powers on that little computer, and that computer does a whole bunch of complex transactions back and forth with the reader. And that's where we get the smart cards and the non-duplicatable format, is there is an encryption key being exchanged between the reader and the credential. So that's kind of how credentials work. At a very basic level, you have the reader producing that electromagnetic field, energizing the credential reciprocates its number, and that number is taken by the reader and passed up the line. Now, you also have different sizes of readers. So the first most common type of reader is probably going to be your short read range readers, and that's going to be a prime example of all of PDK's readers. All of our readers are shorter read range. You might get a little more range with Bluetooth, but for our intents and purposes, we're going to say it's all short range. These are smaller format, usually to the side of the door, and they have smaller coils and generally do not go as far. However, if you go with a third-party reader, you can see I put an HID reader there on the side. That's a medium range reader. You may also have a long read range reader, which is much larger and posted, let's say, on top of a gate to read cars' badges as they roll up to the gate. Those are generally larger because they have those larger coils, and maybe they even produce a higher frequency or have more power running through them and therefore can read credentials from a further distance. So generally the size will indicate just how far that reader will read from. That's not a one-size-fits-all policy, but for this lesson, that's what we're going to assume. Now, going into the next bit here, I want to cover the different types of credentials. And the reason that this is important is because the reader can only read the types of credentials that it has antennas for. So a 125 kilohertz, which is a prox credential, is only going to be read by a reader that has that kind of frequency built into its antenna. So you have to have a proximity antenna inside of there. Now, typically proximity credentials are non-encrypted, and that's just the nature of them. They're a low frequency, they're fairly basic in how they work, and they're pretty slow in communication as well. Your average communication distance is going to be roughly 2 to 4 inches. Now, moving to smart cards, which we covered briefly in the previous slide, those are going to be more intelligent credentials that have effectively a mini computer built into them. Those are typically going to be encrypted and have an average communication distance of 1 to 3 inches. However, those are a much faster communication protocol. Now, long-range credentials, you're going to notice a significant spike in the numbers there. This is just a quick search that I pulled for some of the most common long-range readers. They can range anywhere from 865 to 928 megahertz. Those are going to be long-range credentials. They're high frequency, and they generally have a higher powered reader associated with them. Now you have some other kinds, and you'll notice some overlap here. So we have Bluetooth, which is a 2.4 gigahertz signal, and because of that kind of tells you why not every reader is Bluetooth capable, because it requires a different antenna entirely. We've already covered 3 different types of antennas: a 125 kilohertz, 13.56 megahertz, 800 to 900 megahertz. Now we're all the way up to 2.4 gigahertz. Now, Bluetooth is capable of longer distances. Sometimes that's limited for security purposes, especially for indoor readers, but it will be most generally and most commonly, it'll be 128-bit AES encrypted. Now you'll see we go back to 13.56 megahertz. That is NFC, near field credentials. Smart cards share the same frequency as NFC. Effectively, they are using NFC. These have the least amount of distance, again, that 1 to 3 inches, but it has the highest security capability. So it can range anywhere from 128 to 256 AES. Now, on top of that, I want to cover just briefly, you may have some remote kind of credentials, and those are generally proprietary to whoever manufactured either the reader or the controller or both. And that's unlimited distance, theoretically, if you don't have any sort of geolocation, because it's communicating directly through the cloud to the controllers. So that would be your alternative kind of credential as well. Now, credentials have the option of either being proprietary or non-proprietary. I'm going to start with some common types of proprietary credentials. So the first kind will be probably universally the most common type of proprietary credential you'll run into, which is HID branded credentials. HID has a massive following in the access control industry, and so they have a whole bunch of readers and a whole bunch of credentials. And in fact, they pioneered a lot of these technologies. So they have a whole bunch of proprietary credentials, and I don't want proprietary to sound bad. It does mean sometimes that you can't interchange readers or credentials, but also very commonly it means that you can't duplicate those credentials, and that's really the purpose behind it. So HID has card formats such as iClass, Corporate 1000s, Indala, SIO. They have their own kind of mobile credentials, NFC credentials, MyFair credentials. They have a whole range, a whole gamut of different kinds of credentials, and those are going to be proprietary to HID readers. So that's the first thing to acknowledge. Maybe you're taking over, like, I don't know, you're taking over an access control system. They have existing HID readers. You need to figure out what kind of credentials are being used on that HID reader and make sure that you continue to use those credentials and don't just swap them for something completely incompatible with that system. Likewise, we have Schlage or Allegion credentials with their similar range of proprietary formats. They have smart cards, mobile, MyFair, other credentials that are non-duplicatable. And then MyFair, which has come up actually twice already under HID and Schlage and Allegion, is a proprietary format set forth by NXP. And NXP actually makes these credentials, and they're often white labeled for individual companies. So you'll see a lot of MyFair credentials. And for PDK, for example, that's what we use. Those are MyFair DesFire credentials that we use, the EV3s. So those are generally going to be locked to whichever manufacturer they are made for. Now, in addition, you may have NFC or Bluetooth. NFC is almost exclusively proprietary to that system. You will need to have the credentials issued through the access control software or have some sort of key. It's not something that you can just pick up and jerry-rig for yourself. So those are going to be, for example, like Google Wallet, Apple Wallet, some sort of smart card, MyFair, NTag, it's going to be any number of NFC formats that are locked to that particular manufacturer. Bluetooth credentials are almost always proprietary. I don't want to say always because I have heard of a specific one, I can't even remember what brand it was, that was universally compatible. But in most cases, Bluetooth is going to be proprietary because the Bluetooth key is being issued from the access control system and uniquely coded to that manufacturer's readers so that they work. It's not something that's like, oh, this phone is going to be credential number 12345. It's a little more advanced than that. So Bluetooth credentials will generally be proprietary. Your examples might include HID, Linnell, Schlage, Castle, PDK. Everybody has their own format of mobile credentials. Now, let's move into non-proprietary credentials. These ones are pretty universally compatible across different systems. So the first one, proximity, of course, that one has been in use for decades. That format is pretty universally compatible between different readers, different systems, and even different credentials. It's not always the case. There are certain instances where you may need to take additional considerations. You may need to take additional factors into consideration. But for most purposes, you can generally just take a proximity credential from one system and use it on a different system. Magstripe as well. That is one of the oldest credentialing systems and is almost never proprietary. That said, you probably don't see too much of Magstripe anymore. It's pretty infrequent to see that. PIN codes are also non-proprietary. They are just submitting a number of bits in bursts. So the one consideration you'll need to have here is determining which burst format the access controller supports. Lots of access controllers do support either 4-bit or 8-bit bursts. Sometimes you need to define it, some don't. So you'll need to make sure, A, that the controller supports the burst format of the reader, or B, configure the reader to change the bit burst format. Say that 10 times fast. That's the case with the rugged readers, the PDK rugged readers, for example. You can configure the reader itself to either be 4-bit or 8-bit bursts, and that will just send different amounts of information up to the controller, and then depending on the controller, it can take that information and translate it into PIN codes. All right, so let's quickly cover physical credential differences. So to kind of recap what we've just covered, we have 125 kilohertz versus 13.56, and that is the 125 kilohertz is typically going to not have encryption. It's going to be a little bit slower, and it doesn't store a whole lot of data. If any of you have followed news in the industry, you've probably seen a huge uprising in awareness that 125 kilohertz cards are more vulnerable to cloning. And especially with the kind of hardware that you can get off Amazon. Any average person can go onto Amazon and find a duplication tool to allow them to duplicate those 125 kilohertz cards. Now, does every situation call for higher security? No, not necessarily. Prox is still a standard in the industry and is still used, but 13.56 megahertz will have the benefit of having stronger encryption. It'll be faster. It can store and support multiple applications on board, and it can also provide protection against being duplicated. So, to break it down per communication line here, for lack of a better word, from the credential to the reader, all right, that's our first communication line. We need to communicate between the credential and the reader. And that is going to be done in one of the ways that we've covered, either via Prox, smart card, QR barcodes, PIN, Bluetooth, NFC, magstripe, whatever it is. That's the first determination of what kind of reader and credential you should use on a system. Now, what you should typically consider is generally if you're taking over a site. When you have a brand new system, my recommendation always for people who don't understand card formats or reader technologies is just use the same manufacturer across the board for the controller, reader, and credential, and use whatever they recommend. That's the easiest way. However, in certain cases, you may not have that option, like in a system takeover. So a lot of times when like, for example, we build system takeovers, we replace the controller hardware and we replace maybe the credentials, but we leave the readers intact. So you have to make sure that the new credentials are compatible with the existing readers and that the existing readers are compatible with the controller. So that's kind of the breakdown I'm going for here, if that makes sense. So our first consideration is going to be, is this credential compatible with this reader? So 125 kilohertz, it's pretty obvious. Yes, it's probably compatible. 13.56 megahertz, it may be not compatible. You need to make sure that it doesn't have any kind of encryption key that will prevent it from being decrypted by the reader and passing the correct card number up the line to the controller. Similar with other proprietary formats, you have Bluetooth, NFC. Those are probably going to have to match up, the reader manufacturer and the credential manufacturer. You're going to need to make sure that the encryption keys used are compatible between those two devices. Now, once the communication reaches the reader translates it and sends it up the line. Now, with Prox credentials, for example, or smart card credentials, you're going to have a number of bits. And those bits are going to be zeros and ones that the reader's going to process and shoot up the line to the controller. Now, with PDK's Prox credentials, those are going to be 26-bit credentials. And that means that you have 65,000 possible card numbers and 255 possible facility code numbers. And you can multiply those two numbers together, 255 times 65,000. It gives you a very big number, but it's not infinite. And so the common concern there is, hey, I'm going to run into duplicate credentials by accident, and I don't want to do that. Maybe I don't know all of the existing credential numbers at a particular facility and I need to order more. I don't want there to be any possibility of there being a duplicate. Great, that's fine. Probably what you want to do in that case is move to a higher bit format. So for example, 37-bit credentials, you'll see a lot of those by HID. That has 500,000 possible card numbers alone, and that's without even mentioning the 65,000 possible facility code numbers. And when you multiply those two numbers together, it is, for our purposes, infinite. It is never, well, I shouldn't say never, life finds a way, but theoretically you will never run into a problem with duplicate card numbers on a site, even if you don't know the existing card numbers on site. So as you get into those bigger bit formats, you're going to have less likelihood of card duplicates on site, especially for those larger facilities, and you'll also have more diversity and security built into that. Now, once it's translated and sent up the line, it will be sent up the line as either Weekend or OSDP, specifically with PDK. There's a few other formats out there. Weekend is the older of the two and has been around since the 80s. And the way that works is it uses the positive and negative for power, of course, and then it uses a 5-volt voltage on the data 0 and data 1. And when that voltage is dropped, it translates effectively binary, one way, up to the controller. The controller just detects which lines the voltage is fluctuating on, and it says, okay, it's trying to transmit 1010. Great, it's trying to translate that. OSDP works a little bit differently. It has a much longer range than Wiegand. Wiegand is capped out at 500 feet, and OSDP is 4,000. But OSDP has some additional advantages. One is that it's a two-way communication, so not only can the reader communicate with the controller can communicate with the reader as well. But it also has the option to be encrypted, which it is on PDK systems. It's encrypted, and that means that you can't have man-in-the-middle attacks where you can just read card data as it's being passed through from the reader to the controller. So that's another nice benefit. I'm going to cover OSDP. I don't want to get too ahead of myself here, but let's go into the next thing and cover how OSDP works. So OSDP is new, very new. It was first introduced in 2011, but it was recognized in 2020 by the IEC. It's currently at version 2.2.2. So the format it uses is an RS-485 protocol, and if you've ever used RS-485, you probably know that's a very reliable communication protocol, and lots of access control platforms use that. Now, it only uses 4 wires. It uses the positive and the negative just like Wiegand, but instead of having 1 wire for data 0 and 1 wire for data 1, it transmits over 2 different lines asynchronously. Now, the OSDP standard supports what are called ACKs and NACKs, which is not very creative in my opinion, but I don't know who to take that up with. So we have acknowledgement and negative acknowledgements. So it has some level of intelligence and monitoring built in. And it transmits asynchronously in frames or packets, meaning that it doesn't require a clock like clock and data does. So each packet will start with a start bit and end with a stop bit, and if we go into the next little piece here, it shows the message framing of it. So you have the start and the stop at the start and the beginning, or if I can talk, the start and the end. But the framing is just generally you're going to have your header, you're going to have your command and response code, your data payload, and then your checksum and CRC to ensure integrity. Encryption, like I said, is part of the OSDP standard. I actually just learned this. It's not officially mandated to be put into play in an OSDP application, but it is supported. So that supports AES 128, and as I mentioned, PDK does use that, and that helps prevent the man-in-the-middle attacks, prevents people from tying in a little device in the middle of that line and reading all the card data as it goes through. So OSDP is the best. It gives you higher security, gives you line monitoring, it's bidirectional. You have easier install, requires 4 wires instead of 5. It's interoperable. It has multi-drop capabilities, and I'm going to show you what multi-drop means here on the next page. But whenever I go out and do training with anyone, this is always my recommendation, and my recommendation to you is going to be the same. Always install OSDP whenever possible. It's not always possible, and that's fine. It's not a sin to install Wiegand. It should be, but it's not. So when you have like a takeover and you already have existing Wiegand line, if you're keeping the readers intact, that's fine. Just keep the Wiegand. PDK intentionally still supports Wiegand, and we probably will for a while because it is such a universally recognized communication protocol. However, if you are replacing those readers, my recommendation is to go with OSDP readers. Any new installation, I feel, also should do OSDP installation wherever possible. It may not be that the client is some high-tech, high-security client that is going to need all of the benefits and features and bells and whistles of OSDP. It's more about future-proofing. Another benefit I don't think gets brought up nearly enough is the fact that you can push updates out to the readers. That is hugely valuable. For example, some of these older smart readers, I just did air quotations, you can't see my face, but I just did. Some of these older smart readers are readers that were capable of using, let's say, NFC or Bluetooth, and they communicated over weekend. Well, anytime you needed to push a firmware update to that reader, you either had to take the reader down and send it back to the manufacturer, or you had to load the firmware onto your phone and transmit it to the reader via Bluetooth, which is extremely time-consuming and not at all advantageous for the installer. The benefit of OSDP is you don't even need to touch it. You can translate that data down the line directly to the reader from the access control panel. And that is a huge, huge time saver. If there ever is a firmware update or new features become available on that reader, or a new, I don't know, a new protocol is needed, whatever the case is, you can just transmit it down the line to that reader. I think I've beat that dead horse. Okay, let's get into multi-drop real quick. This is the last slide, so this is just the final piece of OSDP. OSDP, since it is a two-way communication, it can individually identify readers. And so what that allows is for daisy chaining, or multi-drop as we call it. So you can see here we have 4 readers connected to a single reader port. And since each reader is able to individually identify itself and provide its identification number, you can tie up to 4 readers into the exact same line and tie it into one single reader port. Generally, the application where this is most used, I'll say, is probably at gates. Or maybe a badge in, badge out scenario. It basically is just 4 different readers controlling a single entryway. So the only place I've really seen, and maybe you guys have done something really unique here, but the only place I've ever seen it has been at a semi-truck gate. And what they do is they have one low reader for cars and they have one high reader for semi-trucks. And cars can use the bottom one, and truck drivers can use the top one, so they don't have to climb out of their cab and get down to where the car level one is. And then likewise on the secure side of the gate, they have a badge out for a car and for a semi-truck. That's the only place I've really seen for that kind of application. But if you are doing a more typical kind of installation where you have a badge in, badge out, instead of getting 2 separate reader ports, you can just use one reader port and 2 readers tied into that same reader port and just communicate that way. And they will identify separately in the PDK software as the badge in reader and as the badge out reader. And that way you can track the coming and goings of all of the employees on site. So that is all that I have on reader communications. Now, I did see a question come through. If you have not yet done your question, please start typing now, because 30-second delay, and I can only procrastinate so long. So, Tyler, does PDK currently offer any NFC options? NFC, if we go by the definition of like the 13.56 megahertz, yes. Smart cards we do support. The Google Wallet, Apple Wallet options, no. We do have integrations that do allow for that, and I have completely blanked on their name, but if you go into the integrations tab in PDK.io and just search NFC, you will find, is it Access Grid? I can't remember. Anyways, we do have an option that allows you to integrate and utilize Google and Apple Wallet. But the ones that we natively support will be the smart cards using Desfire EV3. I haven't seen any other questions come through, so I will go ahead and wrap up. Once again, like, subscribe, and be sure if you go to the PDK YouTube page and go to the Live tab, You can hit notify me on any of the upcoming videos. We plan these about 3 months ahead, so you can see the next 3 topics. So we have some really good topics coming up. I recommend you go through and notify yourself on those. Otherwise, we can notify you from the website as well and send you an email notification that these are coming up. These are hugely recommended based off of what you and our support team have recommended that we cover. So if you have any recommendations, reach out to us. If you have any questions about anything that we've covered, reach out to the sales team. You can reach them at sales, S-A-L-E-S, at prodadakey.com, and the number is 801-317-8802. I believe they're option 1. And you can reach out to them at any time with questions. But we will plan on seeing you at the next coaching session. Thank you for joining.